Algebra students, we're ready to start Chapter 8. You'll notice that Section 1 is going to have two parts, but bear with me, I'm going to try to move very quickly and get both parts in one video. We're going to be talking about polynomials. Now, we've already talked about monomials, and we're going to now go through some definitions to make sure you're fairly confident. Hello, Algebra 1 students. We're ready to start Chapter 8. You'll notice that Section 1 of Chapter 8 has two parts. I'm going to try to go quickly and get them both on one video. Part 1 is going to concentrate on our new vocabulary, where we're going to be talking about all things polynomials. So first, let's just start off defining what a polynomial is. A polynomial has more than one term. The word poly means many. Okay, so a polynomial basically is a monomial. We talked about those in Chapter 7. A monomial means there's only one term in the polynomial, or it's the sum of monomials. So a polynomial can have only one term, and if it only has one term, we call that monomial. Or if we have a sum of monomials, then that makes polynomials. Now, if that sum is just two terms, like 3a minus 7b, and yes, that is a sum. Remember, that's plus a negative. So if we have 3a minus 7b, I have two monomials in my polynomial. Ooh, that's a tongue twister. So that's called a binomial. So polynomials can be monomials, binomials, and guess what a trinomial is? It has three terms. So say I have 3a minus 7b, and I can add a third term like 8y, and that makes a trinomial. So within polynomials, you have monomials, binomials, and trinomials. Okay, the degree of the monomial is the sum of the exponents of the terms. Now, let that soak in. The sum of all of the exponents of the term. That is what makes the degree of a monomial. The degree of a polynomial, remember there's going to be more than one term to choose from, is the highest degree of any term. So in other words, you're going to look at all of the monomials that make up the polynomial and pick the monomial with the highest degree. We're going to show you what we're talking about in just a minute. Then there's something called a standard form. We've talked about standard form for equations of a line. Well, there's standard form of a polynomial. And I apologize that it's jumping. The standard form of a polynomial is written from the term with the greatest power to the smallest power. So you're going to go from greatest to smallest. And the coefficient of the first term of the polynomial, once you have it in standard form, this is after it's in standard form, the coefficient of the first term is called the leading coefficient. Which makes sense. It's the one out front. It's the leader. But you have to make sure first that it's in standard form. Okay, I'm throwing a lot of terms at you, but just bear with me. I hope to make them all make sense momentarily. All right, let's talk about the degree of a polynomial. So if a polynomial can have one term, here I have a constant 4. That's understood to be 4x to the 0, because anything to the 0 power is 1. So the degree of the polynomial, look right here, it tells us how many times it's going to cross the x-axis. So a constant has 0 degrees. It's not going to be a graph. There's not going to be anything, there's not going to be a line. It's going to just be, a number. Now, if it's linear, like 2x plus 1, we know slope-intercept form. So it's going to be a line. It'll hit the x-axis only once. Now, we're going to spend most of our time here where the degree is 2, called a quadratic. And a quadratic is written x squared plus 4x minus 1. There's 3 terms, so it's a trinomial. The leading coefficient here is 1. Our highest degree is 2. And so when your highest degree, so the degree of this polynomial is 2, it's going to cross the x-axis like it is in this graph. It's going to cross the x-axis twice. Now, as you start going up into higher degrees, your graphs are going to get more and more complicated, and we're going to save that for your upper level math classes. But see, these crazy graphs are passing the x-axis more than twice. This one crosses the x-axis 4 times, so I know it's going to have a power of a degree of 4. Okay, so again, we're going to be spending our time talking about quadratic equations in the next little bit. Now let's go back to those terms. Let's see if we can identify these polynomials based on those notes at the beginning. So first we have to determine if it's a polynomial. And if it is a polynomial, identify if it's a monomial, a binomial, or a trinomial. Okay? So our first one is definitely a binomial. It has 2 terms. So yes, it's a polynomial. And it's the sum of two monomials. And it's called a binomial. All right, the next one we have x squared plus 2xy minus 7. I feel it coming on that it's yes. It's the sum of 3 monomials, so I bet you already know what that's called. It's called a trinomial. Now this next one is not a polynomial. Not only are we seeing a division in this problem, but if we manipulated using what we know about our exponents, the functions of our exponents that we just covered in chapter 7, we would end up with negative exponents, and our polynomials cannot have powers that are negative. So it is not a polynomial. Moving on to the next one, it's a multiplication. It's 26 times b squared. There's no addition or subtraction. So remember, if it's not separated by addition or subtraction, it is a polynomial, but it only has 1 term. So if it only has 1 term, guess what that's called? A monomial. All right, so I hope that helps make the notes on the first page a little clearer. I want you to try this checkpoint. Next, we need to practice determining the degree of the polynomial. Reading from the first page, let's go back. The degree of a polynomial is the highest degree of any term. Now, how do I determine the degree of one term, one monomial? I have to add all of the exponents. So one monomial is the sum of the exponents. So here I have no exponent, so it's 0. Here my exponent is 1. Now for this term I have 2 exponents that are 1, so a total of 2. Here I have 1 and 2, a total of 3. So the degree of this polynomial is 3. For b, I have a term that is 2. The 9, of course, is 0. 0 and 2 leaves us with 2. Here I have a degree of 0 and 1. And then here's just a degree of 0. So the highest is 2. So the degree of this polynomial is 2. I'll let you try C and D. Moving on to example B, where we're going to try to write our polynomial in standard form. And then we'll identify this is supposed to say leading, the leading coefficient after we have it in standard form. So let's first determine our degrees. Here I have 0 and 2, so a degree of 2. Here I have 0 and 6, and 0 and 1. So the highest term there is 6. So we should put the 3x to the 6th in the front. You want your highest degree in the front. And then we go from greatest to least to be in standard form. So this is it in standard form. So what is our leading coefficient? Our lead coefficient is 3. All right. Next we have 0. We have 1. We have 1 and 1, which makes 2. We have 0, 1, and 2, which makes 3. So in standard form, we would write this 8xy squared plus 6xy plus 5y plus 12. And our leading coefficient is 8. I'm going to let you try C and D. Okay, the next two problems are showing how we will use polynomials in real-world examples. So the first one says that from 2000 to 2006, the number in thousands of patients seen by a medical facility can be modeled by this equation. So they're going to go ahead and give us the equation. See how it's a polynomial. It's got 3 terms, where t in this equation is the number of years since 2000. So how many patients were seen in 2005? So that's been 5 years since 2000. So t is going to equal 5. So we'll take our n equals, we'll substitute in place of t, 5 squared plus 2.1 times 5, and there's the cute little clip art making us jump around. And I'll let you all punch that in your calculator and find out that n equals 36.3. But remember that this was n was in thousands, so we need to multiply times 1,000. And we actually have 36,300 patients. I'm going to let you try example 2. Again, they provide you the formula. You're just going to plug in how many years. Now, I know I was going to try to put both parts on one video, but there's no way in 2 minutes I could explain the next couple of pages. So be looking for a second video to go with part 1. Okay, thank you.